Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevron Engineering College. Today in this class we are going to discuss about the topic of flywheels. So this is in the third unit. So I am going to give the theory explanation of the flywheels today. And this is my 33rd class regarding to the subject dynamics of machinery. So first of all, what is a flywheel? So flywheel is generally a mechanical element which simply stores the energy. So generally flywheel is used to store the energy. So a flywheel in essence is a mechanical battery, simply a mass rotating about an axis. So it is a rotating disc about an axis, and these flywheels stores energy mechanically in the form of kinetic energy. So they store in the form of the kinetic energy, and they take an electrical input to accelerate the rotor up to speed by using the built-in motor. These are used by the speed of built-in motor, and return the electrical energy by using this same motor as a generator. So these can be used as generator, and they may still prove to serve as an important components on tomorrow's vehicles and future needs also. So they can be used in the future needs also. Next, so coming to the introduction of the flywheel. So we have already studied that flywheel is a heavy rotating body that acts as a reservoir of energy. So reservoir means they use it to store the energy. So they use it to store the energy and serve the energy when needed. So that is the main purpose of the main function of the flywheel. Next, This energy is stored in the form of kinetic energy. So we use it to store the energy in the form of flywheel, and this stored energy is in the form of the kinetic energy. And flywheel is extensively used in applications like punching press, where the power is supplied at constant rate, and it is also used in the IC engines also. So in the IC engines, power is generated at variable rate, but in the punching press, the power is supplied at constant rate. So that is the two difference between the two machines, that is punching press and IC engines. So these flywheels are extensively used in both the applications, that is in the punching press as well as the IC engines also. Next, the functions of a flywheel. So we need to find the functions of a flywheel. These flywheel are used to store and release energy when needed during the work cycle. So when needed during the work cycle, these are used. Next, to reduce the power capacity of the electric motor. So to reduce the power capacity of the electric motor also, they can be used. And last one, to reduce the amplitude of speed fluctuations. So generally these are used to reduce the amplitudes and fluctuations. So that is why we are using the flywheel. So these are the three functions of your flywheel. First one is the store and release energy when needed, and to reduce the power capacity of electric motor, and to reduce the amplitude of speed applications. So these are the three functions of the flywheel. Next, we need to consider the differences between the flywheel and governor. So they are both the mechanical devices, measuring devices. So they used to both the develop the energies. So first one we used to see the flywheel, and second one is to the governor. So governor is is in the next unit. So we can see it in the next unit and do problems on it. So first of all, we used to classify the we used to differentiate between the flywheel and governor. So this is an important question regarding to the university exams. So flywheel reduces the unavoidable fluctuation of speed arising from fluctuations of turning moment on the crankshaft, so it reduces the unavoided fluctuations. But when coming to the governor, it controls the mean speed of the engine. So generally the governor function is to control the mean speed of an engine. So that is the basic function. Second one, coming to the flywheel, it neither has influence on mean speed nor it maintains a constant speed. So flywheel neither influences the mean speed or it does not maintain a constant speed. But when coming to its governor, it has no influence on cyclic speed fluctuations. So it does not respond to the cyclic speed fluctuations only. So that is the main difference. And third one, when coming to the flywheel, it always remains in the operation when the engine is running. So it always remains in the operation when the engine is running. But when coming to the governor, it only operates when the engine is running away from its mean speed. So when the mean speed is not controlling, then it will be operated from the governor. So that is the main differences between the flywheel and governor. And next, coming to the flywheel, it may not be used if the cyclic fluctuations of output or energy output are small or negligible. So if the cyclic fluctuations of energy output are small or negligible, we may not be used the flywheel. And next, coming to the governor, it is essential for all types of engines to adjust the fuel supply as per the demand. So they are using all types, they are using for the all types of engines to adjust the fuel supply as per the demand. Next, last one, energy stored is in the form of kinetic energy and is 100% convertible to work without friction. And when coming to the governor, it involves frictional losses. So these are the points which differentiates the flywheel and governor. Next, what are the materials used for these flywheels? So what are the materials used for general manufacturing of the flywheels? So first one, it is generally made of cast iron as it has following advantage. So generally these flywheels can be made of cast iron, so casted iron, which is the original iron, and which is casted, that is heated iron. So they have the following advantage. So CA flywheels, that is cast iron flywheels, are cheapest. So when coming to the material of the flywheels, these cast iron flywheels are very cheap because it can easily available. And cast iron flywheels can be given any complex shape without involving machining operations. So these cast iron flywheels can be given any complex shape without involving machining operations. Next, excellent ability to do damp vibrations. So these can have the stability, high stability and excellent ability factor to damp the vibrations, that is to reduce the vibrations. These are the general advantages, but however it has poor tensile strength and its failure is sudden and total. So this leads to the failure and in the sudden way and total done. Next, coming to the construction of the flywheel, and these are two types of flywheels. First one is the flywheel with the web, and second one is the flywheel with arms, so different arms. So you can see it in the picture. So in the first one, the flywheel with the web, it has a rim with a desired thickness and some holes on the web. Web means a plain sheet type solid material. So it has some holes on it, and in the center it has a hub which is used to fix with the other mechanical material, mechanical element. So that is the hub. So these are the main elements. And coming to the flywheel with arms, there consists of the thick rim. So you can see the difference between the web and arms. So there you can see the thin rim, here you can see the thick rim, and the arms are arranged on the above the hub. So there you can see the web is arranged on the hub, but here the arms are arranged with a hollow figure, hollow shapes. That is, you can see the holes there between the arms. So that is the basic difference between the flywheel with arms and flywheel with the web. So these are the basic differences in the construction of the flywheel with web and flywheel with arms. So next we need to see the different turning movement diagrams for the flywheel. So this is the first one. This is the 4-stroke IC engine. So this is starting with the negative loop. So this has 4 types of strokes, that is suction stroke, compression stroke, working strokes and exhaust stroke. So in the suction stroke you can see the negative loop and positive loop. Both the loops are present in the suction stroke, but in the compression stroke you only see the negative loop. And when coming to the working stroke, the energy is arranged here, so there is a positive only, that is why positive loop is occur in the working stroke. And last to an exhaust stroke, it can form the negative loop and positive loop. So we can draw the turning movement diagram with the help of turning movement on the vertical side and crank angle on the horizontal side. This is the first one. And when you see the fluctuations of these energies in the flywheel, first we need to draw the turning movement diagram. So in the model problems also we have seen the construction of the turning movement diagram from the given data. So this is the mean torque line drawn for the turning movement diagram, with the horizontal portion as the crank angle and turning movement as the vertical one. And next it is drawn to the portions. You can see the portions A1, A2, A3, A4, A5 and A6.